Hello, everybody. Hope you're doing very well. Hope you had a good weekend. Today is Monday, and this week we're going to talk about two sections that will not be on the test. Let's talk about the test first. The test is next Monday, September 21st. It's going to be on sections 1.5 and 2.1 through 2.4. I'm going to make an assignment that will be optional, designed as a test review that will kind of have all the things that could possibly be on a test on this assignment, and that is optional, remember. I'll try to get that out within the next day. Now, the sections that are going to be covered this week, again, are not on the test. They'll be on the next test, so you're going to have to organize your notes and your study time and keep these compartmentalized. Just save what we're learning here for another day, but then also carve out time to prepare for the test on Monday. Remember, no retakes, no reassessments. Transformations of functions. Trans meaning change, form meaning the shape of things. So this is a great section because it has such long-reaching consequences. You can, what we're about to learn is you can move any function almost anywhere you want, left or right, anywhere you want, up or down. You could stretch it, you could shrink it, you can flip it over the x-axis, over the y-axis, etc. So we're going to kind of try to discover what happens here. Let's define a function, y equals f of x. So we have no idea what this is. It could be a line, it could be a parabola, it could be something crazy, it could be a sine function, it could be anything, as long as it's a function. And we know one specific thing, that f of 10 equals 3. That means this one ordered pair happens to be on this function. If I were to graph it, 10, 3 would be on that graph. And on the left-hand side, we have all these transformations. And see, they all have something in common. See if you can figure it out before we get to the next slide. What happens when you take f of x plus 8? Well, the only thing I really know about f of x is that f of 10 is 3. So let's see what happens to that ordered pair. F of 10 plus 8, I'm just using f of x plus 8. Well, f of 10 equals 3, and 3 plus 8 equals 11. So 11 is the result. 10, 3 became 10, 11. Now, what was the change? The y value went up 8 units. What about f of x minus 1? Well, again, f of 10, I can plug in f of 10. I know f of 10 equals 3. So I'm going to plug in f of 10 and then minus 1. Well, f of 10 is 3, and 3 minus 1 is 2. So 10, 3 has now become 10, 2. Again, the y value now went down only 1 unit. For f of x. You should read this as 4 times f of x. And order of operations matter. The only thing I know about f of x is that f of 10 equals 3. So I'm going to take 4 times f of 10. That doesn't mean I'm going to do f of 40. That would be breaking the order of operations. I would do the grouping symbol first. F of 10 is 3. So this becomes 4 times 3, which is 12. So now the result, in other words, the y value, is 12. 10, 3 became 10, 12, and I just multiplied the y value by 4. Now, graphically, that looks like vertically stretching it by a factor of 4. So if the range was between -1 and 3, let's say it was a bounded function, it was just hovering between y equals -1 and y equals positive 3. If I multiply that by 4, now it's ranging between -4 and positive 12. All the y values are being quadrupled. 0.1 times f of x. Again, 0.1 times f of 10, which is 0.1 times 3, which results in 0.3. So 10 comma 3 became 10.3. All the y values got smaller. They got multiplied by 1/10. So that's a vertical shrink. And finally, -1 times f of x. Well, that's negative times f of 10, which is -1 times 3, which is -3. So 10, 3 became 10, -3. And what just happened was multiplying the y value by -1. And that reflects the y value over the x-axis. Now, what do all 5 of these have in common? They only affect the range. They affect the y values. So here is the general the general guidelines for changes to the range only, the y values only, only, only. You can move the function up or down, just add or subtract a positive real number. You could stretch it or shrink it, just multiply it by, if you want to stretch it, you multiply it by something that's greater than 1. And if you want to shrink it, something between 0 and 1. And if you want to reflect it over the x-axis, you multiply by -1. It's worth mentioning that, remember, f of x is y. So when you take negative times f of x, you're just multiplying all the y values. So if a y value was up here in the positives, it becomes the negatives. It got flipped over the x-axis. And if the y value was negative, it becomes positive. It got flipped over the x-axis. Here is an example. We have a function. Now we know very clearly this is a quadratic, and it's just a quadratic. It has a vertex of -5, -1. And what does this do to that quadratic? What are the transformations that take place? There are 3 of them. First, the reflections and the stretching comes first. That's important to note. The reflection and the stretches come first. And so the f of x, y, is getting multiplied by -3. So all the y values are, not only are they getting flipped, they're becoming their opposites, but they're also getting tripled. And then after that, all the y values go up 9 units. So the red parabola here was that original function. Notice the vertex is -5, -1. And then -4, 1 is just one random ordered pair on this red parabola. Where does this specific ordered pair get mapped to after these transformations? Well, only the y value is being changed. First, the y value is being multiplied by -3. So 1 times -3 is -3. So this is kind of like the transition ordered pair. And then after the stretch and the reflection, then comes the movement up or down. This is up 9. So the y value at -3 moves up 9, landing on 6. So -4, 6, notice it is on the blue parabola, which is just the result of the red parabola going through these transformations. Again, reflections and stretches always come first. Then the movements up and down. And when I say movements up and down, I shouldn't have to say y value, because only the y value is in charge of going up and down. The x value is in charge of left and right. Well, the x value can change too. Let's do another page here. This is all with the domain values. So here's another function. Don't know what it is. The only thing I do know is that f of 8 equals 6. So there's an ordered pair 8, 6. What happens with all these transformations? Again, another set of 5. What does f of x plus 7 do to the function? Well, remember, the only thing I know is that f of 8 equals 6. So if I want to kind of think about this, I had to think, well, what x value would I put in here so that I can get f of 8, something that I know? And that leads me to x equaling 1. If x equals 1, then this is f of 1 plus 7, which is f of 8, which is 6. So 8, 6 got shifted to 1, 6. Now, what's the difference between 8, 6 and 1, 6? Imagine in your head 8, 6 as an ordered pair, and then 1, 6. The difference is that it moved to the left 7. 1, 6 is just 7 units to the left from 8, 6. And what about f of x minus 5? Well, to understand, to have any idea, any investigation with this function, I only know that f of 8 equals 6. So how am I going to get 8 as an input with x minus 5? I would need to let x equal 13. So if x equals 13, I have f of 13 minus 5, which is f of 8, and f of 8 is 6. So 8, 6 has now been moved to 13, 6. Remember, my x value was 13, and the result was 6. So that was a movement to the right 5. So x plus 7 inside the grouping symbols moves it to the left 7, and x minus 5 inside the grouping symbol moves it to the right 5. What about f of 2x? How do I get to f of 8? Well, x would have to be 4. If I let x equal 4, then I have f of 2 times 4, which is f of 8, which is 6. So 8, 6 has become 4, 6. The x value 4 now results in 6. This results in this is a horizontal shrink. I am essentially dividing all the x values by 2. And then 0.5x, x would have to be 16. So 0.5 times 16 gives you f of 8. And now 8, 6 becomes 16, 6. So this is a horizontal stretch. Again, you can think all the x values are divided by 0.5. And dividing by 0.5 is the same thing as multiplying by 2, which is why 8 as an x value became 16. Here you divide by 2, which is why 8 became 4. Here you go to the right 5, which is why 8 became 13. And here you go left 7, which is why 8 became 1. And finally, f of the opposite of x. Well, this just takes the opposite of the x values. You would need x to be negative 8. So 8, 6 becomes negative 8, 6. And if all the x values become their opposites, then that is a reflection over the y-axis, the y-axis. And here they are in general. If c is a positive real number, then x plus c moves it to the left, x minus c moves it to the right. C times x is a horizontal shrink. You divide by c. X divided by c is a horizontal stretch. You again divide by 1 over c, whatever that fraction is. And then f of negative x is a reflection over the y-axis. Another example. Same red parabola with a vertex of negative 5, negative 1. What does this do to that parabola? Now, it bears repeating. The reflections and stretches come first, then the movements left and right. So here, the x plus 4 is the movement to the left, but that comes last. The reflections and the stretches come first. So this negative 2 I have to account for. It's going to take all the x values, and it's going to take their opposites, which is the negative, and it's going to divide by 2. And then it'll move to the left 4. So negative 5, notice I'm not talking about negative 1. Negative 1 is a y value, and nothing is happening to the y values here, only the x values. So negative 1 is going to stay negative 1. But negative 5 will first be divided by negative 2, so it'll become positive 2.5, and then it'll go to the left 4 and result in that new x value, negative 1.5. Here's an example. I'm sorry, here's a graph of that last example, and this is our last slide. So we have our red parabola function, which is the original function, and here are the transformations, the f of negative 2 times x plus 4. So where does negative 4, 1, where does that get mapped to? All the ordered pairs on this parabola go through the same transformations, the same ride that negative 4, 1 is about to go on. First, stretches and reflections come first. So this negative 2, negative 4 as an x value gets divided by negative 2. That will flip it over on the y-axis and cut it in half because of the 2 right there. So negative 4 becomes positive 4, and then positive 4 divided by 2 becomes positive 2. So that's a reflection, and then the horizontal shrinking. Then you move it to the left 4. So remember we were at 2, so if you go to the left 4, that results in negative 2. And so negative 4, 1 ultimately becomes negative 2, 1. Notice it's flipped over, even on the vertex side. It was originally on the right-hand side of the vertex, now it's on the left-hand side because of that reflection. And it looks like a beginning student might think, well, it only went to the right 2 spots. No, it actually went to the left 4 spots left 4 spots, but that was after it was reflected over the y-axis.